Yeah, I'm gonna, before we take any more questions from the audience, I'm gonna use my moderator power here, because there's an important question I wanna ask, and then we'll get back to the questions with the audience, and we'll start with you, and then Toby and Jeremy. So, each one of you have talked about implementing M2M big data programs. Can you, maybe Brian, we'll start with you. Can you talk about a specific company or client, you don't need to name their names, where you've implemented an M2M solution and the value that they've extracted so far? Sort of give a case study on a specific instance.
Yeah, I mean, actually, I just talked about it a little bit. The one that, so the holy grail in a lot of asset-based businesses is predictive maintenance and basically fixing something before it breaks, or before you even know it breaks. So we've done that for military-grade vehicles in a combat environment. And I guess the case study was, the problem was you have an army moving across the desert at full speed, and it can't stop. And there's obviously lives on the line. So, armies march on their supply chains, and a lot of asset-based value propositions in machine-to-machine really boil down to: do I have the right part to fix something at the right place, at the right time? And so, a lot of our big case studies with big data are about talking to what I call federated sensor networks, or automobiles, or in this case, mobile defense systems, gathering data off them and predicting with a high degree of certainty when they're going to fail. We automatically send notes out to a maintenance system saying, locate the spare part. And then we also send a note out to the supply chain system saying that spare part's about to be consumed. We need to order a new one, make sure it gets back on the shelf the minute that spare part gets consumed. And we've got to locate the right person with the right knowledge to make that repair in the field. In that case, it's fairly easy, because the military does a great job of sort of categorizing everybody into skill buckets. But that same sort of use case, and we've done that for a defense contractor, is basically them offering an OEM service out to their customers. They installed it wasn't a cloud offering, they installed it within their firewall. But it was sort of the genesis of our entire system, was taking that use case, and then we do much lighter weight versions of that in slices for sort of the next generation of folks who are just starting to adopt that model. But a lot of things in this world have actually, even Gert already touched on it, we talk about jet aircraft, and they're flying autonomous robotic systems that can order their own spare parts, at least the JSF and a couple other high-end ones are. Those were a lot of the interesting use cases come from.
Great.
The newer ones are like the ones like I talked about with the automobile manufacturer.
Great. Hinton?
Again, just what was the question? Just can you repeat that?
Oh, just application. I mean, you have so many different uses for M2M data at PG&E. So, a recent one, a problem that you solved using M2M data, and the value that you extracted from
So
it?
it's the implementation that we're doing right now itself, right, on big data, and that is primarily to basically be able to use the interval meter data that is available from the smart meters, along with the customer data, right, that's there. And like I said, the intention is just to provide it to our business units, which is customer energy solutions, so that they can do intelligent analytics on that. Part of the whole strategy is what I was getting to is targeted marketing, right? So, if the interval meter data, kind of can be segmented, and there's different units where, you can provide, different recommendations in terms of energy savings for residential customers versus what a small medium business would do, right? Is there ways where we can, kind of suggest them programs which would kind of help them roll over all the facilities, right? As opposed to kind of, having, a different program in a different building. What does it make sense in terms of the location and different attributes, where an account rep can consume this information, right, and basically make recommendations on what implementations they can do, and then based on which you could give them incentives like rebates, things of that kind, right, which motivate them, right, to participate further. So this is just, like I said, an initiative that has started off in customer care, and there's several use cases, like Gerd mentioned, about transformer load management. Electric Ops it would be is interested in using that. There's federal funding. There's for projects called an EPIC program, which is basically kind of encouraging utilities to invest in these areas, right? To look for what is it they can do for kind of predictive analysis. What is it they can do to kind of merge distribution operations along with kind of transmission management, and what are some of the areas where you can have more situational awareness, so to speak, right? So I'm sure this will kind of proliferate further, and there may be business use cases, but yeah, we started off as customer care initially.
Okay. Good.
I'm actually gonna stay very, very close to what Hiten just described from a utilities perspective. So better understanding customer behavior, customer consumption is a key topic. Why? You can use it, for example, for better forecasting. Once you know what are typical behavior patterns, what happens on a hot day or what happens on a weekend, and so on and so on, you can derive from that what is my energy need going to be, and especially in the days of intermittent renewables coming into the grid, you maybe combine that with weather forecast and so on, and try to improve your forecast on renewable generation, so then you know how much energy you need to purchase in the wholesale market, which can be very, very expensive when you do it at the wrong time. Another one is, and I think you sort of touched upon that, when you roll out energy efficiency programs or demand response programs, who are really the businesses or households you want to target for that? Do you want to target every home in a neighborhood? Probably a lot of them don't make all that much sense. You want to have the 10 or 20 or 30% most valuable ones. So how do you identify those? Another thing we're working on right now is the politically correct term is non-technical losses. So effectively, we're talking about theft. Who's stealing electricity? So when you look at consumption data and something looks a little bit strange, someone has, for example, you take consumption data and combine it with data you would get from Zillow or one of those sites, or quite often it's even in the CRM that a utility has. It's a 4,000 square foot home, but it only consumes a tiny little bit of electricity. So probably there's another cable coming from somewhere else. Those are a lot of applications, and they can either improve efficiency in rolling out new programs, or they can, like theft prevention, that's something that will immediately hit the bottom line and improve profitability for the utility.
Mike?
One of the ones I can talk about in public is there's a lot, but
We want one of the other ones.
because it's being recorded.
Nobody's recording this.
Of course not. So we formed a joint venture with Accenture and created a company called Polaris, which is working with the flight operations groups of major airlines to help them operate their businesses more efficiently, to, in general, keep the time on wing, as it's known for engines, jet engines, to maximize that, optimize that, to burn less fuel, which is also a major cost for airlines, maybe the major cost, and in general help them operate their business more efficiently. And what that joint venture is doing is creating cloud-based services on top of a platform that General Electric has already created, as I was alluding to before, that interprets mostly the streaming data that's coming off of the engines. It's an asset-based application. And there are, we have a joint venture with Microsoft called Caradigm, which is helping healthcare organizations use analytics to increase the operational efficiency that they have. And there's a number of examples in healthcare which are ultimately asset-based. We run national television commercials using people that were in the movie The Matrix to advertise that. But you get the idea. So it's an effort that's being deployed throughout all of the business units, but the most visible things so far are in, at first, healthcare and aviation.
Great, thank you. Yeah, so you had a question?
Oh, wait, you have the mic.
No, she has the mic.
Yeah, I just, this is Lei from UTC.
You might want to stand up.
This is Lei from UTC. I would just notice, when we're talking about this big data, one of the the panelists mentioned about for the health sector is the regulatory kind of a obstacle about how to really, and what's really happening. This gentleman was talking about disruptive technology. I would think the first thing that happen is going to be in the health sector. So you think it's mainly is the regulatory problem? People really cannot analyze all those huge data. The other day, I just looked at a Bloomberg news. They're talking about one of the technology they've been able to analyze all the cancer treatment and then present to the doctors for their decision how to treat the patients. So I just like to hear panelists make some comments on this particular data management and analysis sector.
I'll take the first stab at it because I flagged it as one of the challenges I see in that space. A lot of the constraints that I'm referring to are about bringing the various data sources together into a bigger data pool. Because you need to have a lot of additional attributes in there which characterize the patient. The more you know about the patient, the more you can use that database to find certain trends or probabilities and what works better as treatment and whatnot and all those things. Now there's many restrictions on what you can transmit from one place to another. How do you transmit it, and how much detail can you include on that? So it goes back to the very basis of my premise about big data, which is data integration. Bringing all that together. And I think cancer research could be much more advanced than it is today if we were just able to have better data for them. It's just one example.
Mike,
But also it's about efficiency in the system. Your physician, how much information can he or she share with other healthcare providers? How many tests are being repeated just because you don't have access to existing test results, or you don't know whether you can trust them or not? I think we are wasting billions of dollars on duplication of efforts just because we don't know how to share the results.